Namaste everyone. In this video we're going to see the law of conservation of momentum. Conservation basically means that the momentum remains the same. Neither it gets destroyed nor it gets created. And we are talking about an instance when two bodies are exactly colliding. So let's take the body number 1 and body number 2. So initially, before collision, let us say that they are moving with velocity u1 and velocity u2. At the collision, they are going to make an impact, and after impact they will again start moving away from each other. And let us say the final velocities of these objects are v1 for first object and v2 for the second object. Now the law of momentum, or the law of conservation of momentum, tells us that the momentum before collision is equal to the momentum after collision. Now if we see the diagram, the momentum before collision for body 1 is m1 u1, and the momentum before collision for body 2 is m2 u2, where m1 and m2 are the masses and u1 u2 are the initial velocities before collision. Now according to the conservation law, this momentum will be equal to the total momentum after collision. So m1 is the mass of first object, v1 is the final velocity after collision for first object, and m2 mass of the second object, and v2 velocity of the second object, that is after collision. So this momentum remains the same before the collision as well as after the collision. With this equation we can find one of the velocities if the other three velocities along with masses of both the objects are known. In this particular derivation, I have taken the direct collision, which means the center of the line joining the center of masses of the two objects, which is here, is also the direction in which both the velocities are located, not only before collision but also collision as well. Now in case the velocities are not along the center of along the line joining the center of masses, in that case, let us say initial velocity of first object is u1 in this direction, and the initial velocity of object 2 is u2 in this particular direction. So what to do if the collision is happening in this way? So well, we just have to take the components of the velocities in x and y direction and apply the same equation 2 times. So we'll have to take m1 u1x, ux being the x component of u1. If we know the angle here, that will be equal to u1 cos of theta. Now same way for all the equation, we will have to take x component. So m2 u2x equals m1 v1x, m2 v2x. And for y component, we'll have to take the same equation, except x we will have to go for y components of the velocities. Once you found the unknown velocity, both the components of the unknown velocity, we can combine them using the Pythagorean relations. So that's it for this video. In the next one, we'll take up some problems on the conservation of momentum equation. Thank you.